Hey, AP Chemistry. So, I got a request for a bit of investigation into question number 58. Now, I skipped around a bit and I already solved for the BCA table, so that's a bit of stoichiometry. But I'm going to start tackling how I could use this BCA table to solve for things like mole fraction and pressure. Now, at the end of the BCA table, I got that there, at the end of the reaction, or after the reaction, that there are 0 moles of N2H4 in my reaction vessel, 0.875 moles of N2O4, 0.375 moles of N2, and zero point 0.5 moles of H2O. So the answer to I should be B, because it's actually for the maximum amount of moles of H2O, and so zero point 0.5 moles of H2O, oh sorry, it should be 9, sorry, A. 0.5 moles of H2O is zero point 0.5 moles times 18 grams per mole. That should be 9 grams per mole. So the maximum grams of H2O that could form is 9 grams, so that's A. But now I'm going to start focusing more on the mole fractions and calculating pressure. So the question says that this is a 10-liter container, and it's at 320 Kelvin. Okay? Well, first thing is, I'm going to calculate either mole fraction or pressures. Let me calculate mole fraction so I have some practice with it. Now, mole fraction is represented with this letter X, or chi is a Greek letter X. So, mole fraction, let's say I'm talking about mole fraction of A, is moles of A over the total moles. Right, and so moles of A is whatever A is, and then total moles would be, if I had 3 substances, it'd be like moles of A plus moles of B plus moles of C. Now, at the end of this reaction, we have 3 different types of substances with 3 different moles. I'm going to add these 3 up to get my total moles. And let's say I'm going to do my mole fraction of each of them. I'll show you how I would do that. So I'll do my mole fraction of N2O4. So I'm going to get my total moles. I'm going to do 0.875 moles plus 0.375 moles plus 0.5 moles. So 0.875 plus 0.375 plus 0.5. And I get 1.75 moles is my total moles. All right, so equals total moles. Now, if I want my mole fraction of N2O4, I just do moles of N2O4 divided by 1.75. I'm not going to do it of N2H4 because there's none left. So the mole fraction is going to be 0. Okay? So I'm going to do 0.875 moles divided by 1.75 mole. And that's going to be equal to 0.5 moles. 0.5, sorry, not moles. Right, so the mole fraction is unitless, really, because moles cancel out. So my mole fraction of N2O4 is 0.5. I'll do my mole fraction of N2. It's 0.375 divided by 1.75, right? 0.375 moles of N2. 1.75 is my total moles. If I do this math, I will get 0.21. Okay, I'm rounding here. Let's say this is 0.5 and I have 0.21. All right. Now, there are 2 ways I could solve for my last mole fraction. I don't know if you know this, but the sum of all my mole fractions is going to equal 1. Right? So, mole fraction of A plus mole fraction of B plus mole fraction of C, they all equal 1. It's kind of like percentages. So I could either add these 2 together and then subtract from 1, or I could just solve it. I'll get the same thing. So I'll do my 0.5 moles over 1.75 mole. So 0.5 divided by 1.75, and I get 0.29. Okay, and look at that. 0.5 plus 0.21 plus 0.29, they all equal 1. Okay, so now I have all of my mole fractions. I'm going to stop this video here, so if you were just like, yo, how do you get mole fractions? This is the one that you could use. In my next video, I'm going to continue on with this and solve for pressure.